The last section looks at z-scores. And a z-score indicates how many standard deviations an element is from the mean. And it's calculated using this formula. Z represents the z-score, x is that data value, x bar is the mean, and the sigma is the standard deviation. So standard normal distribution is a normal distribution that has a mean of 0 and a standard deviation of 1. We're going to determine the z-score for the value of x. So z equals, and here my formula, I have x subtract x bar. So my x is 36, my mean is 165, and I'm dividing it by the standard deviation of 48. And we get an answer of negative 2.688. We're going to determine the z-score. Oh, sorry, that's the same question. Here we go. Determine the percent of the data to the left of a z-score of 1.24. So here they're telling us what the z-score is, and I'm going to show you how to use the z-score to find a percentage of population that is lower than you, so to the left. So here you can just Google these tables. We have a positive table, so all these z-scores are positive. That means they're to the right of the average. So if I was to draw our normal distribution, oh, it's not letting me. Okay, it'll let me on the picture. So if I was to draw the normal distribution, your average is in the middle. All these positive values are all to the right of your average. So I need to find 1.24. And how I do that on my z-score, on your left columns. So all these guys here are representing the first digit before the decimal and the first digit after the decimal. So I need to find 1.2, which is here. And when I run along the top, this is giving me the decimals that are second. So there is my 0.4 on this column. I'm just going to run your fingers across so that they meet up. And we get 0.89251. And if I want to represent that as a decimal, I just have to times it by 100, or sorry, a percentage, times it by 100, and we get 89.25%. So that means 89.25% of the population is lower than this set of data. Determine the percent of data to the right of a z-score of negative 2.35. So one thing to notice, it says to the right. So this is like asking, well, who is better than this piece of data? On your tables, it only tells you to the left. So I'm going to show you how to solve for this one. So we need my negative table. Your negative table is showing all the values to the left of your average. And we have negative 2.35. So here's my negative 2.3. This is my table for 0.05. So I'm going to run my finger through until I match up. And it's 0.0093. I think that was a 9. 0.900939. So if I was to times that by 100, 0.9% of the population is below me. So I'm going to put below 0.09%. If I want to know to the right, I'll take 100 and I'll subtract that from 0.09. And I get 99.1%. So 99.1% of the population is above. Determine the percent of data between the following z-scores: negative 2.88, negative 1.47. So negative 2.88 is 0.00199. I'm just going to round that to, if I was to times it by 100, I get 0.199, so I'm going to round that to 0.2. And at negative 1.47. Times that by 100 and I get 7.08 when I round. So I'm going to round that to 7.1. So I don't know the percent of data between these two z-scores. You'll take your bigger number, subtract your smaller, and you get 6.9% of the population is between the following z-scores. IQ tests are sometimes used to measure a person's intellectual capacity at a particular time. IQ scores are normally distributed. So if I was to graph them, it would create a bell curve with a mean of 100 and a standard deviation of 15. If a person scores 119 in an IQ test, how does this score compare with the scores of the general population? I'm going to draw my picture. It's not necessary, but I do like to relate it back to my last slide, a normal distribution. So each 15 is a standard deviation, so if I go above, I have to add on 15. And if you remember from last lesson, we also had those percentages in here. All right. See, when we were doing the normal distribution, it worked well to figure out the percentage of people in between a interval, so between a standard deviation. But when I'm dealing with z-scores, it's when I'm dealing with a data point like 119 that doesn't fall right on an interval. So 119 is somewhere in here. And I'm going to find the exact population using the z-score and that z-score table. So remember that formula, z equals your data, subtract the average divided by a standard deviation. We're going to use that to figure out what the z-score is. I have 19 divided by 15, and that's 1.266, so I'm going to round that to 1.27. To find the percentage, I need to jump back to that z-score table. I'll go to my positive one, and I'm looking for 1.2, which is here, we've used it before, at 1.27. So I'm going to run my finger across until I get to 0.07, and here is the percentage that lies left of me. So to change that back into a percentage, I'm going to multiply it by 100. So that's 89 point, and I'm going to round that to 8. 89.8%. So, if you were to score 119 on an IQ test, you would be more smarter than 89.8% of the population on that day. And if you're curious to figure out, well, who is better than you, you have to take that percentage and subtract it from 100. So 10.2% of the population would have done better. In this example, we have athletes which should replace their running shoes before the shoes lose their ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640 kilometers, with a standard deviation of 160 kilometers. Zach is an elite runner and wants to replace his shoes at a distance when only 25% of the people would replace their shoes. At what distance should he replace the shoes? So in this example, we're given the mean, we're given the data point, and we're given the percentage. So what we need the z-score still. We have the x-bar. We have the standard deviation. And I'm looking at what distance, so that data point. I can get the z-score from a z-score table. I know that 25% of the people, when they replace their shoes, is when what's his name here? Zach wants to replace his shoes. So if I turn that back into a decimal, that's 0.25. So I'm going to go to my table, and in these decimal ranges, I need to find the closest to 0.25, and these ones are way too high. So that means I'm over at the negative z-score table. So I'm looking for 0.25 in this table. And let's see. We have some 0.25 values here. So I'm going to look for the one that's closest. So the one that is closest would be this value right here, which is happening at a z-score of negative 0.67. So I'll go back to my slide. So the z-score is negative 0.67. I'm going to double check that again. Yep, okay. And I'm going to set up my equation now. Okay, make sure I have my formula correct. Good. I'm going to multiply both sides by 160. And I get negative 107.2 equals x, subtract 640, add 640 to both sides. And I get 532.8. So 532.8 kilometers is when Zach will replace his shoes. You guys to do your practice questions. Practice number 5, questions 1 to 7.